Alright class, so today we will discuss the hybridization in carbon dioxide molecules. Alright, so this is the ball and stick model for carbon dioxide molecules, where the black color is carbon atom and the red colors are oxygen atom. So you can see, if you compare the Lewis structure and the ball and stick model, you can see there are two pi bonds between carbon and oxygen atoms, right? Okay, so now in this case, in carbon dioxide molecule, carbon and oxygen atoms undergo hybridization. So let's start how to describe the hybridization process of each atoms in this molecule. Okay, so basically, so you can see around carbon there are two electron groups, 1 and 2. So carbon undergoes sp hybridization. Alright, around the oxygen atom, at the right side oxygen atom, we have 1, 2, 3 electron groups. So the oxygen atom undergoes sp2 hybridization, and same goes to this oxygen atom. It undergoes sp2 hybridization. Okay, next. Alright, so by referring to the Lewis structure of carbon dioxide, you can see around between carbon and oxygen atoms there are two sigma bonds and there are two pi bonds. Alright, okay, so now let's start the hybridization process for carbon atoms. So basically you have to refer to the electronic configuration of carbon: 1s2, 2s2, 2p2, and later on we will use the electronic configuration for oxygen atom. Alright, okay, so the ground state of carbon atom, 2s2, okay, because we are going to, we have to refer to the valence electron of carbon, and 2p2. Right, okay, if you refer to the Lewis structure, there are two sigma bonds. So to form two sigma bonds, carbon needs two unpaired electron, and in this case, in the ground state there are two unpaired electron present, and in two s orbitals there are paired electron. But if we do not promote the electron from 2s orbital, it looks like later on carbon has lone pair, so it is totally wrong. So even though we have already two unpaired electrons, we have to promote one electron from 2s to 2p orbital. So the next step is promotion of electron. So we have 2s1 and 2p3. Alright, earlier before we already determined the type of hybridization of carbon atom, where carbon atom undergoes sp hybridization. So carbon mix its 2s orbital and one of its 2p orbital to form a new set of hybrid orbitals, which is called sp hybrid orbitals. And there are two 2p orbitals that contain electron which are not undergo hybridization. So we have to write down here 2p orbital which is unhybridized, and it has two electrons. Alright, so from the Lewis structure, from the sp hybrid orbitals in the orbital diagram, you can see this electron in two sp orbitals will be used to form the sigma bonds, and for this one it will be used to form the pi bonds. Alright, okay, settle for carbon atom. Next, continue with oxygen atoms. And since the oxygen atoms, both oxygen atoms undergoes sp2 hybridization and they are identical. Okay, they are identical, they are same. Okay, so we just draw and describe the hybridization of oxygen atoms once, right? Okay, so now by referring to the Lewis structure, okay, in the ground state, refer to the valence electron of oxygen, 6 valence electron which occupy 2s and 2p. Right? And in order each oxygen atom to form one sigma bond, alright? So forget about this another one because it is same with this carbon. So in order to form one sigma bond with carbon, oxygen needs one unpaired electron. So in the ground state, in the orbital diagram of oxygen, there are 2 unpaired electrons occupied 2p. So we don't have to promote the electrons, so just rewrite the ground state orbital and electrons and copy in the promotion of electron step. And each oxygen atom undergo sp2 hybridization. So oxygen makes its 2s orbital and 2p orbitals. So sp2 hybrid orbitals of oxygen is formed, right? And we have one unpaired electron which occupies 2p unhybridized orbital of oxygen. Okay, and from the orbital diagram, sp2 hybrid orbitals, this represent the lone pairs on oxygen atom, this lone pair and also this lone pair, and this electron, alright, will be used to form the sigma bond, and the electron which occupies 2p unhybridized orbital will be used to form the pi bond with carbon atom. Okay, so now let's draw and show the overlapping. Okay, so this is the sp hybrid orbitals of carbon and its it's unhybridized orbitals, and this is the sp2 hybrid orbitals of oxygen and its unpaired electron which occupies 2p unhybridized orbital. Okay, so let's start with the central atom, right? The central atom is carbon atom. So this is the Lewis structure as a reference. Alright, so let me use this red color of marker. Okay, so carbon atom undergoes sp hybridization. So it has sp hybrid orbitals. So sp hybrid orbitals, the electron group arrangement is linear, and from the molecular shape you know that carbon dioxide has linear shape with bond angle 180 degree. So this is the sp hybrid orbitals of carbon. Okay, so let me label it here sp. So let's say this is I put the label carbon here. Alright, so in each sp hybrid orbitals of carbon, one unpaired electron occupies. Okay, so now I want to show to you how the sigma bonds between carbon and oxygen form. Alright, so carbon has 2 sigma bonds. oxygen has one sigma bond with carbon atom. Each oxygen atom has one sigma bond. So this is the pair. Alright. Okay, so oxygen atom undergoes sp2 hybridization. Right, so we have to draw sp hybrid orbitals. So sp2 hybrid orbitals which has a trigonal planar arrangement. Okay, so let me label it here. Okay, let's say oxygen, and these are the sp2 hybrid orbitals of oxygen. 3 sp2 hybrid orbitals of oxygen, and in the overlap region there are shared electrons with opposite spin. Alright, so now the first sigma bond is formed. Alright, but if you refer to the orbital diagram, okay, 2 sp2 hybrid orbitals of oxygen occupy by lone pairs. So these are the lone pairs. Okay, and same goes to the to another carbon, right? Okay, so let me label it here. Alright, sp2, sp2, sp2. So in the overlap region we have shared electrons with opposite spin, and the sigma bond is formed, and 2 from 3 sp2 hybrid orbitals of oxygen occupied by lone pair. Alright, okay, so now settle with the sigma bonds. Alright, settle with the sigma bonds. Okay, so now we are going to show how the pi bonds between carbon and oxygen atoms are formed. Alright, okay, so there are two pi bonds between carbon and oxygen atoms. Alright, so this electron will be used to form the pi bond with oxygen atom. Alright, so let say the both 2p unhybridized orbital of carbon are 2py and 2pz. Let's say. Alright, so I draw the 2py first. Let's say 2py, but I label it as 2p. Okay, so let's say this is 2p, so it contains one unpaired electron. Okay, so this 2p electron will form a pi bond with electron from 2p unhybridized of oxygen. So let's say this is also 2py. Okay, okay, I want to use the, let's say, brown color. Alright, so label it as 2p also, and here there are opposite spin electron. So overlapping between these orbital will form one pi bond. So settle for the right side, for the left side. Okay, so now we are going to show the formation of pi bond between the right side of carbon oxygen atoms. Alright, okay, so let's say this is the 2py, 2pz of carbon, and actually 2px, 2py, 2pz, they are perpendicular to each other. So we have to draw another 2p orbitals of carbon like this. Alright, and label it as 2p, and it contains one unpaired electron. And same goes to oxygen atom. It has 2p unhybridized orbitals, so let me label it as 2p here. Okay, and it contains unpaired electron with opposite spin. Alright. Okay, when these orbitals overlap, it forms another pi bond. Okay, and if you compare with the molecular shape of carbon dioxide, the orbital overlapping is aligned. So carbon dioxide has linear shape with bond angle 180 degree. Okay class, so that's all for the hybridization of carbon dioxide molecules. Okay, thank you.